our question today here was based on coordinates. The diagram shows the trapezium ABCD, and then these are the coordinates, and also this line is parallel to this line. AB is parallel to DC. We need to find the coordinates of C, so we have to find coordinates of C. So first of all, I'm going to find the equation maybe of this line and then that line, solve them simultaneously to get C. So finding the equation of this line is very easy. We need to find its gradient, which is perpendicular to this one. So if this one has gradient 8 minus 2 divided by 3 minus 1, so the gradient of AB is 8 minus 2 divided by 3 minus 1, which is 6 over 2, that is 3. Therefore, the gradient of BC, and BC turns out to be negative 1/3, because product of perpendicular gradients, perpendicular lines, the product of the gradient should be equal to -1. Now from here I can find the equation of BC, so that is going to be -1/3 x plus c, and the coordinates on this line is 3, 8. So I can say 8 here minus 1 over 3 x plus c. C turns out to be, and what is x? X is basically 3, so 3 here. 3 goes in 3, 1, 1, so C is 9. So I got then y is equal to minus x over 3 plus 9. So if I want to find the equation now of, let's say, DC, that is this line here, and well, DC has equation y is equal to mx, 3x plus c, because the line is parallel with this one, it's got the same gradient, and this point here is 5, 4. I can substitute y for 4 and x for 5, so 3 times 5 plus c, so it turns out to be -11, because 15 goes on the other side. 4 minus 15 is 11. Equation of the line DC is y is equal to 3x minus 11. We can solve this and this simultaneously. We're going to get the coordinates of C. So let's do that. So what we're going to do, let's try, say, solving. So we get then minus x over 3 plus 9 is equal to 3x minus 11. So that means if you take this on the other side, it's going to become minus x plus 27 is equal to 9x minus 33. So now from here I can say that 10x is equal to 60. So that means x is equal to 6. So if x is equal to 6, I can find y. Y is basically minus x over 3, so minus 6 over 3. Or you can say 3x minus 11. So 3 times 6 minus 11, which is then 18 minus 11, 7. So I've got then 7. So therefore the coordinates of C is 6 and then 7. Here we are, done. First part of the question is over. Let's find the second part. We need the point E lies on BD. There's a point E here, and is such that the area of CDE is 1/4 area of CDB. So CDE, this one here, is 1/4 of the whole triangle here. So this is 1 and this is 3, because 1 plus 3 is 4, 1 over 3 is 1 over 3 plus 1 is 1 over 4. So we have something like this, 1 here, and this is the point E, that's D. So this is the point B, and that's the point, let's say O, because from here to here we got OE. They want us to find the coordinates of, so we're going to do it by vectors. So this is 3, 1 over 4. So 3 times OD, 1 times OB. So we're going to do it by ratio theorem, all right? By ratio theorem, I can say 1 times OB is OB plus 3 times OD, okay, divided by 1 plus 3, and you can get OE. So what is OB? OB is 3/8. So 3/8 plus 3 times OD, and OD is 5/4. So I have then 3 plus 15, which is 18, and then 8 plus 12, which is 20, and all of that should be divided by 4. So if you divide this by 4, you're going to get 4.5, and then 5. That's basically my answer. So therefore E turns out to be 4.5 and 5. Here we are, done. So this is for E. Now I want to, the point F is such that CDFE is a parallelogram. We can see this is a parallelogram. And now they want us to find the coordinates of F and the area of the parallelogram. So the coordinates of F, we want to find this coordinate here. Remember, this is a parallelogram, so this is parallel to this. I can find the vector EC. So let's find the vector EC. EC is, by geometry of vectors, is EO plus OC. So what is EO? Well, we just found OE, 4.5 and 5, so that's going to be then minus 4.5 and then minus 5 plus OC, and C was found to be 6, 7. So let's take our calculator here. 6 minus 4.5, we got 1.5. And then minus 5 plus 7 is 2. So we found the vector EC. So where do we go from here with that vector? Remember, this is EC. It's parallel and equal to this one. So FD is equal to EC. And we know by geometry of vectors that FD is equal to FO plus OD. So if FD is equal to FO plus OD, so I can say FD, which is EC as well, that's 1.5 and then 2. That's FD. It's equal to FO. We're trying to find OF plus OD. And OD, sorry, 5, 4. So I can say then FO is equal to 1.5, 2. This can go on the other side, minus 5 and then 4. So I get then 1.5 minus 5 is minus 3.5. And then 2 minus, this is minus 2. Now this is FO, and I need OF. Therefore, OF is the opposite vector, negative vector of this. So this is 3.5, 2. Therefore, the point F was found to be now 3.5 and then 2. Here we are, done. We need to find the area of the parallelogram FDEC. Alright, so CDFE. Alright, so let's find this. We can do it by modulus, the method. So area of parallelogram. So parallelogram is CDFE. That's going to be half the modulus of, let's look at all the coordinates. Let's start with the first coordinates here, maybe coordinates of 6, 7, 5, 4. Then we go on F, which is, we just found F to be 3.5 and 2. And also I've got E, which is 4.5 and 5. And finally to close up with 6, 7. So now from here I can say half into modulus of all the x's. So 6 times 4 is 24, 5 times 2 is 10, 24 plus 10 is 34. Alright, plus this times that times this, plus 3.5 times 5, 3.5 times 5, yes. Okay, turns out to be 51 point this, plus 4.5 times 7. And I'm getting 83. Minus the y's, 35, plus 3.5 times 4, plus 2 times 4.5, which is 9, plus 6 times 5, which is 30. So 88. That turns out to be half into modulus of this minus that is minus 5. We know that the absolute value of minus 5 is 5, so I got 5 over 2. That's the area, which is then 2.5 units square. So here we are. And this question was covered in the tuition today with Hashim. I'm sure you're gonna be able to catch up with it. And here we are. Take care.